Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called The Even Diagonal by Pagedo or Pagodo. I'm not sure how you pronounce it. Anyways, here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. The positive diagonal must contain the digits 1 to 9. That is this diagonal, because as you increase on x, you also increase in y. That's why it's called the positive diagonal, because you have a 1-to-1 ratio, which is positive. The other diagonal only contains even numbers, so that means this diagonal only contains even numbers. The digits along the orange line must differ by at least 4. So along this line, which is even, along this diagonal, which is even, we have an orange line where the digits along it must differ by at least 4. And this is called the Dutch Whisper rule set. Right. So, okay. As an example, let's assume that we don't have the even diagonal thing. So if this were a 3, this would have to be a 7. We would celebrate because there's a 3 in the corner, and we would have to have a 7, 8, or 9 next to it because along a Dutch Whisper line, which is what this orange line is, you must have a difference of at least 4 between cells, adjacent cells on it. Digits along the green line must differ by at least 5, and this is called the German Whisper line, which is the green line. And if this were a 3, instead of being 7, 8, 9, it could only be 8 or 9 next to it, because it obviously has to have a difference of at least 5 between adjacent lines. Adjacent digits on a German Whisper line. Digits on the purple line are a non-repeating consecutive set in any order. So this is the Renban line. So digits along this line must be non-repeating and consecutive. So for example, if this were a 9, you would know that you would have to have a 5, a 6, a 7, and an 8, because the only consecutive set of 5 digits that 9 is a part of is specifically 5, 6, 7, 8, and 9, right? Because it's consecutive and it's non-repeating. Obviously, if you tried to add a 4 or something to it, it doesn't work because it's no longer consecutive. And that's how Renban lines, or the purple lines, work. Cells with a gray circle must contain odd digits. So all of these circle cells must be odd. Cells with gray squares must contain even digits. So all of these square cells are even. A black dot indicates adjacent digits are double the value of the other cell. Not all dots are shown, and these are called Kropke dots. And specifically, this is called black Kropke dots. So for example, if this were 2, this would have to be a 1 or 4 to maintain the 1 to 2 ratio. A V indicates adjacent cells sum to 5. An X indicates adjacent cells sum to 10. Not all V's and X's are given. So for example, if this were a 2, this would have to be a 3, and this would have to be an 8, because these two digits add up to 5, and these two digits add up to 10. And that's what they indicate. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so first things first. If this is a Dutch Whisper line and the even diagonal, or the negative diagonal, is all even, then you can only have 2 in the middle, because that's the only one that's 4 away from both from two other numbers that are even, right? 4 is 4 away from only 8. 6 is only 4 away from 2. Actually, I guess it could be 2 or 8. Oh, that's interesting. Either way, you have 2 or 8 in the middle. So you always have 2 or 8 along the diagonal, too, then. So this is 2 or 8. This is 2 or 8, and this is 2 or 8, right? This has to be specifically 2, 4, 6, or 8, and this is specifically 2 or 4, because it cannot be greater than 5 between two, if you have a V between two cells, right? It's either 1, 4, or it's 2, 3. And this is, so this is 2 or 4, this is 1 or 3, which means this is 7 or 9 to add up to 10. We know... We know this red band line, it must be either 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, or 5, 6, 7, 8, 9. And anyways, they all contain a 5. So these are all have a 5 in it. This always has the 2 or the 8 along the diagonal, because if this is 2, it has to be with 6 and 8. So this would be 6 or 8, 6 or 8. If this is 8, this would have to be with 2 or 4 and 2 and 4. But either way, the 2 and 8 have to be along the essentially the negative diagonal or the Dutch whisper line. So this is 2 or 8. These are 2 or 8, and this must be 2, 4, 6, 8, and this is 2, 4, 6, or 8, 2, 4, 6, 8, 2, 4, 6, 8. This is in a 1 to 2 relationship, okay? Interesting. These are all odd. And you can never have a 5 on a German whisper line, because 5 is 5 away, or in a normal Sudoku puzzle, because 5 is 5 away from 0 or less, and 0 cannot be in a normal Sudoku digit, and it's also 5 away from 10 and above, and 10 is obviously not a digit. Neither is anything above it. So this is 1, 3, 7, and 9. In these even spots. Can this ever be 7? I guess so, right? It could be 2 and 1 that way. Hmm. Hmm. Okay. One thing on German whisper lines, though, is it always alternates between highs and lows, right? Because if you have a digit from 1 through 4, what can it be next to? Well, 1, the minimum, plus 5 is 6. So that means the neighbor always has to be 6 or above, right? So if you have a 1 through 4, you always have a 6 through 9 next to it. But take a look at 6 through 9. What can its neighbor be, right? Take a 9, which is the most that you can have in the 6 through 9, and then subtract 5 from it. That leaves you 4 and below. So 1 through 4 must always be next to a 6 through 9, which then must be next to a 1 through 4. So it'll always alternate between lows, which is 1 through 4, to highs, which is 6 through 9, and then back to lows, high, low, high. So it always switches which set you're on. So whatever set this is, let's make this pink. It has to be next to the other type of set, which is orange, which also then must be next to pink. So then these two are pink, which means these two must be orange, which means these are pink, and therefore this is orange, and this must be pink. So we know this has to be the same set no matter what. So either it's this is 1313 and this is 7979, or this is 7979 and this is 1313. Interesting. This is in a 1-2 ratio with something, though, so it cannot actually be 7-9, so therefore it must be 1 or 3, which means this also has to be 1 or 3 because it's the same set, so they're both low. So the orange set is low, so we're going to make that blue, and the pink set is high, so we're going to make that red. Therefore, this is low, this has to be a high, which means this 7-9 and this 7-9. These are low. This is 1 or 3, which means this is next to 2 or 6. Interesting. So one of these sets have to be 1, 2 specifically. So this is 1, 2, 3, or 4. This is 1, 2, 3, or 4. This is 1, 2, 3, 4. This is 1, 2, 3, 4. 1 could be in a relationship with 2. 2 can be with 1 or 4. 3 can be with 6. And 4 can be with 2 and 8. Similarly, this is 6 through 9. We just don't know which one it is. Hmm. What else do we have? Hmm. 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 Interesting. Okay. Similarly, actually, on the Dutch Whisper line, since they're all even, you'll either be between 2 or 4 or 6 or 8, right? If you have a 6 or 8, what can it be next to? Well, 8 can only be next to 4 or lower, which is 2 and 4. And if you have a 2 and 4, what can that be next to? Well, 2 as the lowest can go only up 4, which would be 6 and above. So that will also alternate between highs and lows, but we don't know which one's highs or lows, so we're going to make this one orange and this one pink. So this is orange, which makes this pink, which makes this orange, which makes that pink, which makes this orange, and this is pink, so therefore this is orange. So these two must be the same polarity, I guess. And okay. So this one must be the opposite polarity of this one, right? And this one sees the cell, and this one sees that cell. So they both see that cell, and they're opposite polarity. So one has to be a 2, and the other one has to be an 8, which means 2 and 8 both see this cell because of the positive diagonal and then normal Sudoku rules in the row. Therefore, this can never be 2. This has to be 4, which makes this 1, which makes this 9, which makes this a 7. Therefore, this is now 1 or 2, because 7 only can be next to 1 or 2 on a German whisper line. This can no longer be 4. This can't be 2. This could still be 4. Oh, and these two digits also see all of the digits here. This digit here, right? This because of the positive diagonal, and this one because of normal Sudoku rules. And again, both 2 and 8 see that cell, because one of these has to be 2 while the other is 8, and or vice versa, right? If this is 8, this has to be 2, because it alternates sets. And these are different sets. So therefore, they both see this, which means 2 and 8 cannot be here, which forces this to be a 6. Which means this can't be 6, so this is 2 with 1. This can't be 2. So all the pink cells are high then. And all the orange cells are low. Therefore, this has to be an 8. This is an 8. 8 is next to 4 and 2, so this has to be 4, which makes this a 2, which makes this an 8, because it has to be 4 away from 4, which makes this 2, which makes this 6, which makes this 2, because it has to be 4 away from 6, and it can't be 4, obviously, so therefore this is a 4. So this cannot contain a 2, so 1 and 2 are ruled out here. This is 3 or 4. It has to be with specifically 6 or 8. This can't be 2 either. This can't be 7, so this is a 9. Okay, what set of digits on a Renban, which is 5 consecutive non-repeating digits, can not have a 6? Well, the only one possible then is 1, 2, 3, 4, 5. So we know these are 1, 2, 3, 4, 5. And this can't be 1 or 2. This can't be 4. This can't be 2. And the rest remaining must be 7, 8, or 9. This can't be 8. This can't be 8. This can't be 6. But now we have a 7, 8, 9 triplet in row 7, which eliminates 7, 8, and 9 from the rest of the row, which forces then this to be a 6. Where is the 8 in box 7? It has to be one of these two cells, which means it eliminates 8 from the rest of the row in row 7. So this cannot be 8. This is 7 or 9. This can't be 6. This can't be 6 or 8. This 6 must next be next to a 1 on a German whisper line. So therefore this is 1, this is 2. This can no longer be 1. So we have a 3, 4, 3, 4 pair in column 3, which eliminates 3 and 4 from the rest of the column, so this can't be 3 or 4. These can't be 2 because of this 2. Where is the 2 in box 7? It has to be here. Similarly, 4 cannot be in column 1 because of this 4. Where is the 4 in box 7? It has to be here. And the rest, okay, so where is 1 in row 7? Can't be here because of this 1. Can't be any of the other cells that are filled out. Can't be this one because that can't be 1. Therefore, it must be here. So this is 1. The rest of the cells then are 3 and 5. But this can't be 1, so this must be a 3, which means it must be next to 8 and 9 specifically on a German whisper line. So therefore, this has to be 8, and this has to be 9. 8 is next to only 3 on a German whisper line. Therefore, this is 3. This has to be 6 to be a 1 to 2 ratio with it. And therefore, this is 4, which makes this 9. Because the 4 has to be next to a 9 on a German whisper line. Therefore, this can't be 3. This has to be 5, which makes this a 3. And now, we're probably... Well, okay, there's also the the positive diagonal. I was going to say we're probably just doing normal Sudoku, but we also are probably using the positive diagonal too. Where is the 4 in box 2? It has to be here. How about the 4 in box 8? It must be here. Which leaves, you can't have a 4 here, you can't have a 4 here, you can't have a 4 here, so this has to be a 4 in box 5, which means in box 6, this has to be a 4. Ones. Okay, let's look at 2, 5, and 6. This specifically has to be 5 or 6. This has to be 5 or 6. Where's a 2 in column 8? It has to be here. So we should have all the 2's then essentially set. So this would be a 2 because of what's eliminated in box 4. And then this must be a 2 because we have 8 of the digits now, which eliminates all the other possibilities except for 1. So that's a 2. This has to be, what, 3, 7, and 8 here. We have a 3, 7, 8 triplet in row. Okay, this can't be 8, this can't be 8. Where is the 8? It has to be here. We have a 3, 7, 3, 7 pair in row 9, so that eliminates 3 and 7 from the rest of the row. Therefore, this can no longer be 3. Where is the 3 in box 7? It must be here. We also have a 1, 5, 1, 5 pair now in row 9, which eliminates 1 and 5 from the rest of the row. So therefore, that means this can't be 5, so this has to be a 6, which makes this a 5. And what's the last digit in row 9? This has to be a 9. And what we have here, we have specifically, this is a 5, 7 pair in row 8, which eliminates 5 or 7 in the rest of the row, which means this has to be 9. These can't be 9. This can't be 8, therefore this is a 7, which forces this to be 8. We have what's remaining here, 1, 5, and 7. So this could be 1, 5, or 7. That's fine. What about this? This has to be 1, 3, 5 as possibilities, and it cannot be 3. Therefore, it has to be 1 or 5. This is 1, 3, or 5, but it can't be 1 because of that one. This is 1, 3, or 5. That's fine. Let's see. We have a 7 or an 8 here with 1 or 5. Therefore, we have a 1, 5. Okay, so this can't be 1, 5, or 8, so therefore it must be 7, which means neither of these can be 7. We have a 1, 5, 8 triplet in column 1, which means the rest of the column cannot contain 1, 5, or 8. Therefore, they must be 4 and can't be 4 or 9. It has to be 6 and 9. This can't be 9 because of this 9. Therefore, this is a 6, which makes that a 9. What's remaining here? It has to have a 7, and it has to have 1, 5, or 8 with it. So this is 1, 5, 7, or 8. This can't be 1, 5, or 8, so therefore that's a 7, which means this can't be 7. We can't have an 8 along this because we have an 8 on the diagonal, and there's the positive diagonal must contain the digits 1 to 9. So therefore, this cannot be contain an 8 because you have to have 1 of each digit. And since you have to have 1 of each digit on the positive diagonal, you cannot have we have a 1, 5, 1, 5 pair along the positive diagonal, which means 1 and 5 are eliminated on that diagonal. We also have 2, 4, 6, and 8 already, so therefore the remaining cells are 3, 7, and 9. Well, this can't be 7 because of this 7, and this can't be 9 because of that 9, so this must be the 3. We're looking for 7 and 9 now. This can't be 9 because of the 9, so therefore this must be 7, which makes this a 3. Which means this can't be, and it's 3 in the corner. We celebrate. This can no longer be 3 then. Where's the 3 in box 1? Cannot be here, so it must be here. So this is a 3. What's the remaining cell in row 3? This has to be a 5 then, which means this can't be 5, so this is 7, this is 5. What else are we looking at? We have remaining cells here as 6 and 9, but this can't be 9, therefore this is 6, which makes this a 9. The remaining cell, okay, now well, this can't be 3, so this is 7, which makes that 3. This has to be 1 or 5. This specifically has to be 3 or 8, and this is 3 or 8, but that can't be 3, therefore this is an 8, which makes that 3. Therefore this can't be 8. Where is the 8 in box 4? It must be this cell. This is what's remaining is a 1-5 pair here. Therefore, we have a 1-5, 1-5 pair in column 1, or sorry, row 1. That eliminates 1 and 5 from the rest of the row, so this must be 7. This has to be a 6 just because of what's left. Because we have the 1-5, 1-5 pair here, what's remaining is a 7 here. So, wait, that doesn't work. Huh. Oh, we have 2 3s along this diagonal. This isn't a 3. How did I get a 3 here? This is 9. Anyways, yeah, that's bad. That was, I don't know how I got a 9 there, or how I got a 3 there. Just wasn't thinking very well. Okay. Anyways, we have a 1-5, 1-5 pair in row 4, so 1 and 5 are eliminated from row 4, so this does have to be an 8, which means this can't be 8. This can't be 3, so this must be 7, which makes this a 3. This is 3 or 5. This is 3 or 5. That's fine. What do we have remaining here? This can't, that's 6 and 9, so this can't be 9. Therefore, this must be a 6, which makes this a 9. This also has to be a 1-5 pair. This can't be 7 because of that 7, therefore this is 5. This is a 5, and this has to be 7. What we have remaining here is 3 and 8, but either of them could be 3 or 8. What we have remaining here is 3, 6, and 8. This can't be 3 or 8, so therefore this is a 6, which means this can't be 6. This is 3 or 8. What's remaining here? What's remaining here is still 1 and 5. What's remaining here has to be a 6. And what's remaining here has to actually be a 7. So that's, yeah, that's where we went wrong previously. So this can't be 7. We have a 1-5, 1-5 pair now in row 1, which eliminates 1 and 5 from the rest of the row, which means this is to be a 3, which makes this an 8. This can't be 8, so this is 3, which makes that 8. This 3 means this can't be 3, so this is 5, which makes this a 3, and makes that 5. Therefore, this can't be 5, this is 1, which makes this 5, which makes this 1. This can't be 1 or 5, so this must be 7. This can't be 1, so this is 5, which makes this a 1, which makes this 5, which makes this 1, which makes this 5, which makes this a 1. And if you don't accidentally put in the wrong digit along the positive diagonal, that's the solution, and it should be pretty quick. Yeah, pretty straightforward. Definitely easy in difficulty level. I did like actually the trick with the Dutch whispers, because normally you don't alternate between highs and lows on Dutch whisper line, because you could actually could have a 5, which would change the variant how the sets work in a Dutch whisper. But since they're all even, you're definitely then forced to have a low and then a high set, and which alternates. And you normally have that in a German whisper line, but it's cool to see that sort of that idea sort of come through also on the Dutch whisper line with that even diagonal. Very cool. And I hope you had a cool time of it, and I'll see you next time on Frank Puzzles. Take care.